Good morning, everybody. I'm Boelo Schuur. I'm Scientific Vice President of the European Federation of Chemical Engineering, the EFCE. I'm a chemical engineer by training, and I have received my degrees from the University of Groningen in the Netherlands. After hanging around a bit at different universities, since 2011, I have been working at the University of Twente, where currently I am a full professor, Sustainable Separation Technology. And I'm very happy to be involved in the introduction of this webinar on sustainability, and specifically circularity for safe and sustainable value chains. I'm looking forward to participating to it. My role is to introduce the Spotlight Talk concept and also the EFCE in general, which I will now do. Let me start with the Spotlight Talk series. This is the 6th year that we organize the Spotlight Talk sessions, and after the COVID pandemic, we have decided, based on the success of these sessions, to maintain the Spotlight Talks on the calendar, even though we have our regular and in-person meetings taking place again. For example, this year from 8th to 10th of September, we have the big European Conference on Chemical Engineering, ECCE ECAP in Lisbon. And so for that reason, we don't have a fall session this year, only the spring series. And this spring, we will have 10 Spotlight Talks organized by 11 of our working parties and sections, including chemical engineering applied to medicine, sustainability, chemical reaction engineering and process intensification, comminution and classification, mechanics of particulate solids, fluid separations, polymer reaction engineering, static electricity, crystallization, and finally the early career chemical engineers. And we are already a few days into our sessions. We started on the 14th of May and we continue through the 22nd. We may enjoy these short sessions of 3 or 4 talks focused on specific topics by leading industrial and academic experts. The complete program is available on the EFCE website, efce.info, and you are encouraged to explore the other sessions as well. The EFCE promotes scientific collaboration and supports the work of chemical engineers in 30 European countries, representing more than 100,000 chemical engineers throughout Europe. EFCE's working parties and sections cover all the major aspects of chemical engineering, and they are the core of our organization. They form the scientific engine that drives many of the EFCE's activities. They provide an important forum for technical exchange and networking among chemical engineers in Europe. In each of our working parties and sections, highly skilled engineers gather. And I would like to invite everybody to have a look at the website, efce.info, to explore our scientific groups. Maybe you are interested in joining one of our sections. Joining a working party is on invitation only. But if you see that your country is underrepresented and you feel that you are a potential representative or you know a highly skilled individual in your domain of chemical engineering, then please reach out to us and your national member association. Before concluding, I would like to thank all the people who have worked hard to allow for this new series, and in special Martine Pou from Toulouse, who is the engine behind all these activities and did a lot of the work. And now I would like to wish you a great and fruitful webinar. And I would like to give the word to Antonis Kokossis, the chair of the section on sustainability, to introduce the section and the speakers of today. Antonis, the floor is yours.
Yeah, thank you very much, Boelo. Thank you for the introduction. I'm Antonis Kokossis, I'm chair of the sustainability section. My CV is on the web, so I will skip everything about myself. Instead, I will start with a welcome, to our second Spotlight seminar. In case you have missed the seminar and the webinar yesterday, the presentation will come up to YouTube and you can attend, the webinars there. Or you can also visit our website to register your interest and participate not only in Spotlight events, but also in other conferences organized, by the section. As sustainability is broad, we entertain also a broad and steady stream of topics that help us, bring the engineering sustainability community together. And in my turn, I would like also to thank Martine, because the Spotlight seminars have been great to consolidate our community to that purpose. And again, we remain grateful to Martin and her team, in providing this sort of service to us and to the community. List of topics, we have covered so far include, we're a newly established section, we ran second year. We have topics in chemical recycling of plastics, production of renewable plastics, education that have been in the past and they will be in the future. But in the pipeline, we plan to continue with renewable energy sources, carbon capture, fuels, biorefineries of different types, like, oleo and algo biorefineries, waste to energy type of initiatives, of course, circular economy, social engagement of LCA, and also the business intelligence part or the data engineering, aspect of sustainability with methods, and KPIs to monitor supply chains. And a very, very complementary, relevant topic to that, and to LCA in general, is the one that we service with this couple of spotlights. And this one that addresses safe and sustainable by design type of initiatives, which is a flagship framework that has been pioneered and has been promoted by the European Union. Is unique, if you wish, for Europe to ensure that chemicals, materials, whatever products, are produced, so that they are sustainable by design. Looks pretty similar to LCA, but it's an expanding kind of and embracing type of concept, because it includes issues of prevention, issues of safety. What LCA has, as a subsystem, sustainability throughout the life cycle, but also integration into innovation, along, say, the European Green Deal, for instance, and also transparency and responsibility across the supply chain, which again is room, for data engineering and analytics. But each different supply chain may be more or less prepared to expand, its scope, and evaluate it for this embracing concept, of SSbD. And this session today shares examples of important supply chains in textile, in energy materials, in plastics, packaging. Hopefully explaining gaps, opportunities, and the scope to apply safe and sustainable by design principles. Select supply chains, fall within the priorities of the European Union. The Irish project, for which we discussed yesterday, has included additional supply chains, that you can also find in the review, also from the publications of this particular project. But I think this is enough for an introduction. Probably time to give the podium to our first speaker, Franz Lutz. Franz, I know from many, many years in the past when he was still at Eurotex, a pretty active and dynamic individual. He enjoys 25 years of professional experience, has founded and leads the European Textile Technology Platform, and has been previously a director of Eurotech that I mentioned. And Lutz disposes a very rich knowledge and an unparalleled network of contacts, in the European textile innovation ecosystem. Has successfully coordinated several large-scale European kind of projects, and has organized many more European textile innovation events. He is an advisory board member and program committee, for the Textile Research Conferences and Industry Fairs. He holds degrees, in business administration from Germany. He has background in political science from France and executive MBA from the Blerick Business School in Belgium. I think this is enough, Franz. Please share the podium. Thank you for being with us today.
Thank you very much, Antonis, for the kind introduction. So you have heard, I'm not a chemical engineer, but I'll do my best today to bring you some technical information that you may find valuable. Let me first share my screen, that you can see what I'm talking about. Here we go. See if we can put full screen. All right. So
yeah, make it full screen.
Yeah. So can you see it full screen?
Yeah.
Okay. All right. So yes, again, good morning and welcome to everybody. It's my pleasure to be here. What I will do this morning is I will talk to you about the application of the safe and sustainable by design concept in the textile value chain. The work that I present to you is part or has been part of a EU-funded project called IRIS, of which you see the logo also on my slides. The IRIS project, which is coming to an end actually this very month, has been a 3-year project funded under Horizon Europe. I will not explain to you too much about IRIS. The following speaker, Anne-Chloé, will do that. Naturally, we should have switched our presentation, but since I have to leave right after my speech, we had to do it this way around. So Anne-Chloé will explain you everything about IRIS. For me, it's just to say that in this project, we explored, let's say, we piloted the application of SSbD concepts and methodologies in 7 different industrial value chains, of which the textile value chain that I represent has been one. And I want to bring you some results for that. So our case study, which we didn't carry out on our own as the European Textile Technology Platform, we had experts in the organization, in the project that worked with us, the Swiss Textile Research, the Swiss Material Research Center, EMPA, which has textile material experts, and also the Dutch Research Institute for Safety and Security, RIVM. And then we involved a number of industry experts along the value chain that we selected. Obviously, the textile and clothing industry is a very diversified industry. So when you talk about textiles and clothing, people usually think about the clothing that they wear. But textiles are used for, or textile materials used for many different domains. And also clothing is not only that what we wear in our free time and that we often refer to as fashion, but there's also types of clothing that are used in work environments and also in hazardous working environments. And these types of products are technically referred to as personal protective equipment. And so we selected this specific textile value chain for our study. Why did we do that? Because first of all, it is a rather well-organized and mostly European value chain. As of course, many of you certainly know that a lot of the textiles and clothing that we consume in Europe is not made in Europe. But when it comes to these highly functional, highly engineered products, a lot of that is indeed manufactured in Europe. It is among the various end markets in the textile sector, the only one that is really regulated. So there is a strong regulation in place since already 1989, when the first EU PPE directive was adopted. It has been revised over time. So there are very strict standards and regulatory requirements if a company wants to introduce a product that is certified to protect against specific hazards in the work environment. And in order to protect effectively against these hazards, in this protective clothing, you use quite a lot of advanced materials. You use a lot of functionalizing chemicals. You also have relatively complex assembly of different materials, of different layers. And there's also a strong drive for innovation, for improving not only the protection, but also improving, for instance, comfort of these materials, because obviously you want to be well protected, but on the other side, you also want to wear something that is comfortable, that is as light as possible, that is breathable to some extent. So all these kind of things drive innovation, driving new developments, driving the application, or the exploration of new materials and new finishes for these type of products. But there are various challenges related to that as well. There are the known challenges related to chemicals, substances of concern or known hazardous chemicals that are being used partially for specific requirements in the sector. Circularity is becoming a very big issue as well, and you can imagine that a product like that is as complex as that may be quite difficult to make circular, to repair, to reuse, to recycle. Resource efficiency, of course, like in every industry, is an issue, and there is a lot of regulation coming down on specifically for this sector, but also broadly for all sectors that use materials, that use chemicals, that potentially have effluents and all these kind of things. So this is basically what we do. To give you a bit of an overview of how this supply chain, this value chain actually looks like. It's a fairly typical picture for the textile and clothing value chain in general. So you start originally with textile fibers, which can be either of natural origin, such as cotton or wool, or of man-made or synthetic origin. So these are either the synthetic fibers, such as polyester, polyamide, acrylics, or polypropylene, and so on. Or man-made cellulosic fibers like viscose and lyocell and so on. So then these fibers are made into yarns. Yarns are then either woven or knitted into fabrics. And then those fabrics are dyed and finished to give the material the required functional property. And then those materials are made into the final garment. And then those go into typically a professional distribution channel when it comes to protective clothing. There's also a lot of companies in this value chain that rent or lease these professional garments. So they're not bought by the end user, but they are rented or under leasing contract. So these rental companies are also then providing the professional care and maintenance throughout the entire use phase. And then obviously there's the end of life phase. And then what you see here in light blue is areas where chemicals play a role in this value chain. And you can see that they play a fairly important role. So they are chemicals that go into obviously the agricultural side of natural fibers. You have then processing chemicals and a very wide range of processing chemicals that are used along the whole sort of fiber to finish textile chain. And then we have then obviously in the finishing stage, specifically the dyes and the finishing chemicals to give the functional properties to the material. And then you also use, obviously, during the care and maintenance phase, you use detergents, and you can also, in certain cases, refunctionalize, refinish a garment to give it, let's say, the property. Perhaps from the personal use, you may know that there are cases where you can refunctionalize, let's say, a raincoat by applying a finish again to make it waterproof again. So these are things that are happening, and we see wherever you see a star popping up, we identified that there are activities there are processes there that have relevance to SSbD. So that just as a background. So then what we did in our study with the actors from the supply chain is we looked at what are the typical SSbD challenges for workwear protective clothing. And we split them into three buckets, so to speak. There is everything related to safety, which obviously comes first here because these products are meant to protect the safety of the user of the product. And also, obviously, their general safety, worker and employee safety issues that you have in every manufacturing process. And you have that in the manufacturing process of textiles and clothing as well. Then there's a long list of sustainability-related challenges, the three pillars of sustainability, the environmental, the economic, and the social sustainability. And you see that on the environmental front, there are specific challenges related to pollution prevention, especially in the wet processing stages where you have obviously effluents from your wet processes, which are often heavily chemically loaded that you need to treat. There is obviously also use of energy, water, and a lot of chemicals in those processes. Of course, the industry has greenhouse gas emissions. There are issues related to the durability, the circularity, the end-of-life management of those products. And yes, there are obviously also, since a lot of the materials we use, there are synthetic fibers. There's also the issue of microplastic or also functionalized microparticles loaded with chemicals that can be released during the production, the use, and the end-of-life phase. And then there are a few cross-cutting challenges, such as ensuring a good supply chain collaboration, data generation, processing, data exchange, and then the follow-up of all the regulatory developments, and also general issues related to education and training of the staff in all safety and sustainability-related subjects. So to make it then more practical, as some of you may know, that the SSbD framework has essentially two components. You have the design phase or the redesign phase if you redesign a specific material or product, during which you can use as a guideline the SSbD design principles, which you see here on the right side of my slide, of which there are 8. And then once you sort of apply these principles, then if you identify specific materials that or chemicals that you then can subject to a safety and sustainability assessment specifically. So what we did in our case, we stopped at phase 1. So we really looked at the SSbD design principles. And if you want to apply them to the workwear and protective clothing sector, so we didn't pick out a specific material or specific chemical because we wanted to make that relatively abstract framework approachable, practical for companies. You have to understand that most of the companies in this sector are SMEs. They're small to medium-sized companies, very focused on a specific process or value chain stage. So for them, they don't really have very elaborate processes in-house. So we really tried to make the SSbD design principles relatively practical. So we collected input in this process related to the typical processes used and the product elements. And then we evaluated to what extent the design principles can be applied, and also especially which kind of knowledge and information was needed, and which let's say knowledge holder has to provide this information and this knowledge in order to make this assessment. So here you see an overview of some of the insights and challenges that we have identified. When it comes to functionality, of course, protection and the safety of the use of the product is the number one primary concern when you make protective equipment. So they are known hazardous substances or substances of concern that are used today for achieving various functionalities. Thinking, for instance, about flame retardant functionalities and so on. If you phase them out or you replace them with substitutes, you face sometimes the reduction in the functionality, or certain existing chemicals even have multi-functionalities. And if you replace them with substitutes, sometimes you may maintain one of the functionalities, but not the full set of functionality. So that is a concern. We also see that the innovation process to develop these safer alternatives is relatively slow. That has to do with the fact that obviously chemical innovation is costly, given all the development processes, the scale-up processes, the various assessment costs and so on. And then we look at often markets here with relatively low volumes, often niche applications. So that creates a challenge for innovation. If the costs of innovation are high, but then your end market is relatively small, well, then you may not recover actually your investment. So companies are reluctant to innovate in this area. Specifically for the personal protective equipment, some of the functionalities we can only achieve with highly engineered materials. So some of these extreme conditions that, for instance, firefighters or so on face, it's not easy to replace the materials that we use or the chemical finishes that we use. And the other issue also is that, as I said, there are a lot of SMEs in this industry which control very well a specific stage of that supply chain, but they have relatively limited impact on driving changes across the supply chain. Because what we have to understand, and that applies, I think, in many other industries, if you change a material, if you change a functionality at some stage of the supply chain, it often has implications on other stages of the supply chain. So if you replace, for instance, one chemical fiber with another in the, let's say, in the spinning of the yarn phase, you may then create problems in the dyeing phase because, well, for polyester, dyeing is a different process than for instance, cotton dyeing. So if you replace materials, you often also have to adopt the processes afterwards, the technology, the machinery, sometimes the provider who provides the process. So, and that is, for SMEs, is very difficult to drive that. So if you have an industry where you have big companies either at the beginning or the end stages of the supply chain, if you think about, let's say, the automotive industry, where the automotive suppliers or the automotive the OEMs are driving the entire supply chain, let's say, this is not the case in this industry. So it's much more a supply chain of many specialized SMEs that sort of feed into each other. On the safety side, it's very important that the functionalities that you provide in those PPE products remain permanent. So they remain for the entire life cycle of the product. So that means they have to often withstand 50, sometimes 100 industrial washing processes. And that is quite a challenge. Then you have trade-offs, of course, often between cost, the market size, market demand, and sustainability, and then the substitution of some of those substances of concerns that are common in this sector. It remains often a challenge for various reasons, either for functionality or for cost related issues. On the sustainability side, what we face, especially a lack of good data, really comprehensive data, existing standards, good LCA or product environmental footprint methodologies that are established, that are known in the industry, they're used in the industry. That is really a big challenge. Then we still face, obviously, also in protective clothing, some imports of materials, of products, which not always fully align with EU regulation, the slow innovation cycle that I already mentioned. And so what companies do is they try to integrate safety, sustainability in R&D and compliance functions. But they also struggle in terms of their competitive positioning against, of course, often lower cost imports that may be favored by the market because of their costs, but may come with other sort of sustainability or safety challenges related to it. I think here I will probably be quick also in the interest of time. So some practical learnings for our stakeholders is that we really had a very good presence across the entire value chain, which is very important, because if you lack specific knowledge holders in the supply chain, it's very difficult to run a good process. There was some pre-existing knowledge of some of the SSbD principles. So for instance, end of life related, so design for recycling, for instance, or design for reuse or repairability is something that is already practiced. Other aspects are maybe less known. The good thing was that obviously, as it's a regulated industry, you have very clear technical requirements that are defined in standards. So you know what kind of standards you have to meet, but it makes it also challenges then to replace then certain chemicals with something that may be considered more sustainable. But if you then do not meet the technical standards, it's basically it's a no-go. So that's I think is one of the biggest issues here. Very few companies had really full knowledge or really deep knowledge of the SSbD framework, but that was the whole reason why the IRIS project also existed, to bring that new framework to the industry. most of those products here are purchased through procurement, industrial or public procurement processes that are often very conservative. They're not necessarily very conducive to innovation. So these procurement specifications sometimes have not been changed for sometimes 10 or more years. So bringing innovation in such a relatively conservative market is not easy. And it's still a very cost-driven market. So, and that also limits, obviously, the return potential of any innovation that you bring. So, as sort of final conclusion, what we came up with this sort of very simple graph where we say, okay, depending on how critical the functionality is that you want to reach in your product, the more, let's say, you favor obviously the functionality over the, let's say, sustainability dimension. And the more the functionality is a kind of a nice to have, then you can, let's say, bring sustainability more into the spotlight. So if I want to give you a very practical example, imagine you have a piece of workwear that let's say an outdoor, let's say, road construction worker has to wear for 8 hours, and it has to protect that worker against rain for 8 hours. That is a very critical functionality that you cannot compromise on. If that same jacket is something that, well, people buy because, well, they use it for, well, going into the city to go for some shopping. Well, if your jacket doesn't withstand rain for 8 hours in a row, that may not be such a big issue. So there are issues here. The more critical the functions are, the more the sustainability in a way takes a backseat, because there are always trade-offs. And that I think is the main message in a way, to say that there are trade-offs between the safety and the sustainability sometimes, or the functionality and the sustainability, that you really have to balance against. Some of the critical aspects for the application of SSbD in, I think, this industry and in many other industry is really, especially among the smaller companies, the lack of resources to really do these full SSbD assessments. Also economic constraints, cost constraints that hinder this full adoption. The issue of the high risk environments, specifically to these PPE products, the lack of data, lack of standards, lack of well-established assessment methods, especially in the sustainability domain is an issue. Price sensitivity in markets where you don't have much of a margin to absorb costs of innovation. Then strictly regulated market, they limit what you can do in terms of or how much you can actually use these trade-offs of sustainability versus functionality. So if you have to meet a standard according to the regulation, well, then you have to meet it technically or functionally, and you can't just say, okay, well, now my piece of firefighter gear is much greener, but it doesn't protect the fireman anymore. So that is obviously not an option. And then always this the issues that we see in especially in public procurement processes, that cost is usually the factor number one, and sustainability becomes sort of as often as criteria number whatever on the list. So that is challenging. So in terms of recommendations, that's really my last slide here. What we see is that for industry progress, larger companies use these frameworks, find it much easier to use these frameworks also as a competitive positioning tool. So just to show how they are prioritizing safety and sustainability, to differentiate them also from competitors from lower cost countries that may not be as sophisticated in that respect. For the smaller companies, SSbD we see initially more as a structuring approach that helps companies to think more more methodologically about the whole safety and sustainability of their products, of their processes, of their solutions. There's a big focus right now on the elimination of hazardous chemicals from the industry, and here the SSbD framework can really help. But we need industry-specific guidance as well, tools for education of all the stakeholders. We need to promote it more so that awareness in the industry rises, and really collaboration is key. Collaboration along the full value chain, and in our case, especially with the providers of the chemicals that are used in the industrial processes and the industry users of those chemicals. And obviously, SSbD is not a legal framework, it's a conceptual framework, so that right now can be provided very flexibly. But if at some stage it will enter into a regulatory process, then it would probably pose big challenges for especially smaller companies. So we have to keep it as flexible as possible. And with this, I think I'm pretty much in time. Here's my contact information if somebody wants to follow up. And now I'll hand over back to Antonis.
Thank you very much, Lutz. That has been quite an enlightening presentation, and you've been excellent on time. Let me also remind people in the audience that they can put all their questions in the chat. I see, well, I see something now. I mean, it's a question about recording. Recording is on, yeah, from what I understand, and you will be able to get this kind of webinars on YouTube, and Martin is organizing all that nicely over the years, so you can have it. I see no other questions, but well, so let me find some questions. Trade-offs you mentioned. First of all, you know, I mean, it has been important that we have textile industry. It's such an important industry, you know, and Europe has a leading edge on that. Lutz, you mentioned trade-offs, you know, and by design, you know, I mean, the question actually I have is how much the industry is aware of these trade-offs, you know. In SSbD, we give an emphasis for production, you know, at the design stage, you know, that will lead to sustainable kind of products. But by design, you know, I mean, the fashion industry, you know, may have to sideline some of these issues. Fancy colors are difficult to decompose, for instance. Again, the fashion industry, I mean, may have to sideline these kind of trade-offs because, let me put it bluntly, if you want to look beautiful, you may somehow forget, at least temporarily, about sustainability and go for the fancier kind of materials and colors rather than go for something which is more recyclable and sustainable. Do you think that they are prepared, you know, for this kind of trade-offs in this subtle industry of textiles?
It's a very good question because, I mean, fancy colors is a functionality in the same way as let's say fire protection is. It may not be as critical, let's say, if you look at it from a life-saving aspect, but for certain consumers, it's very critical to be able to wear very fancy designs and so on, and for the industry it's important, and it's really, especially when we talk about sustainability and circularity, color is a very interesting question that is often underestimated, because especially also if we think about recycling textile material, one of the big issues is, well, what do you do with the color? If you mechanically recycle textiles, the color remains in. If you chemically break it down, okay, you can get rid of the color. But also if you want to use, let's say, more, for instance, bio-based dyes, for instance, you will not be able to find in nature some neon colors. You won't find a neon yellow or green or whatever, or pink. So this is something where you say, well, is that something that we really need? Is that such a high functionality? Again, if you're a worker in the working in on the road in bad light conditions, yes, you want to be highly visible. If you're a consumer and you go to the beach, maybe a less fancy color does it as well. So color and dyes are an important issue. An interesting issue also is to see that, for instance, when we look at dye stuffs, basically the entire dye stuff industry has left Europe. Textile dyes are pretty much not made in Europe anymore because it was not seen as a growth industry by the chemical suppliers, the big chemical groups that used to provide textile dyes. So a lot of the dye stuff development is done now for markets with higher volumes, which are obviously the markets in Asia. And that also creates big challenges for innovation. So to finding those experts in the chemical industry say, well, let's develop new textile dye stuffs, and not only develop them in the lab, you find researchers to do that, but then scale that in an industrial process. Because again, as I also explained, well, you have the dye stuff, but then you need the dye process. You may have to adapt machinery as well to use different dye stuffs and so on. And that is quite complicated, and that's something that makes replacement of chemicals in an industry as, let's say, complex as the textile industry, often very, very slow.
Thank you so much. I mean, if you allow me, second question. I mean, you said the industry is highly regulated, and you are yourself behind so many developments, and you are aware of things. I mean, do we have figures? Figures are possibly more available than in this industry than other industries. How much you can estimate is recycled back to production lines? I mean, after the usual reuse cycles for textiles, how much is actually recycled back to some sort of production lines? And again, being very close to emerging technologies as well, you've seen, technologies, either fiber to fiber kind of recyclers or fiber to other useful others. I mean, useful others, I mean, excluding the obvious, use as energy feedstock. I mean, what is your view on that? Again, how much do you think is recycled back to production? And out of the technologies which are not yet mature, which ones you would see more promising in the future?
It's a big question, and I could go on for half an hour easily. But right now, to say how much of textile waste, and let's say post-consumer waste, is recycled back into textile materials used again in the textile industry, almost nothing. We're talking about sub 1% of volumes, and that has not changed over many years, which is to do with basically with the fact that textile products, especially post-consumer products, are extremely complex, and to recycle them into a clean material again is complicated. And the other problem is that virgin fibers are extremely cheap. So to compete with virgin fibers with a recycled fiber is extremely difficult. So without regulatory intervention, which is on its way, I don't think we'll see a very rapid development in terms of what processes to use. Well, you have mechanical and chemical processes. Mechanical processes are somewhat easier to develop, and you can do that also at smaller scale. Whereas chemical process, you need big scale. So the mechanical process, I would say, are a bit nearer term, but they have limitations in terms of the quality of the material that you achieve. As I said before, the colors are not removed, and also in mechanical process, you shorten the fiber. So you destroy, as you tear a material apart, the average length of the fiber shortens, which makes the quality of the yarn that you make out of it lower. So that's problematic. Whereas if you chemical recycle back to the oligomer to the monomer, and then you repolymerize, you can basically build up a fiber that is basically as good as pretty much as good as a virgin fiber. So, but it's a more complex process, it's a more costly process. And also, quite honestly, the LCA values are not looking necessarily that great. And you probably remember our Resintex project where we looked at it, and obviously, in pilot scale, those LCA figures are very good, but even in a fully scaled scenario, they're very challenging. So it's a long way to real recycling. So they're downcycling, there's recycling of material for other applications in in the construction sector, in the interior sector, insulation materials, and so on and so forth, which happens already today at some scale. But it's the vast majority, I think 80 to 85% of all post-consumer waste is either incinerated or landfilled.
Thank you so much again. I mean, I hope we will keep you close to our community to give us more recent updates, about this important supply chain. And to that level, I would like to come to our next speaker. Our next speaker is Anne-Chloé. Anne-Chloé is the CEO of Safe-and-Sustainable by Design. She comes from France, but this is actually working now in Spain. She works everywhere, from what I know. She holds a master's degree in chemistry and chemical engineering from the École Nationale Supérieure in Montpellier. She is the CEO of this newly founded initiative, consulting company, which supports other companies and research organizations adopting SSbD approaches. Anne-Chloé's career includes her tenure as a senior innovation manager at the European Chemical Industry Council, CEFIC, and this is where I came to know her first time. And there she spearheaded the innovation policies, secured funding opportunities, and coordinated a huge number of projects and coordinated the SCEM national technology platforms, that have brought sustainability communities from all over Europe, into a unified umbrella. She has extensive industrial experience also that spans, in her leading roles at ICI, Huntsman, Repsol, all of these posts, where she specialized in R&D, research, development, and management, and materials innovation. So it's a special pleasure to have you, Anne-Chloé, with us today. And the podium is yours, for your presentation on SSbD and energy materials in general. Thank you.
Thank you for the introduction, Antonis. Thank you to have invited me to present on this fantastic experience that we had with this IRIS project, combining so many value chains, and that I will try to present today what we have been doing, an overview, because we are in such a time, but hopefully present you the opportunities for the future for all researchers and all stakeholders of your organization to join this SSbD journey, right? And circularity, because I understand circularity is the theme of today. Just to show you also what circularity, how circularity has been debated, developed in this project. So now I'm sharing the presentation.
Yes. Yeah.
Okay. So first of all,
if you want to get in the presentation mode, so thank you.
Is that fine? Okay. So yeah, I just would like to give a bit of an overview of all the different value chains that we've been working with in this IRIS project. And as Lutz mentioned, I give a little bit more information on this and a little bit of focus on the case studies, 2 case studies that we did on energy materials, because yeah, it's important, materials. So that's my first slide, because just like to just presenting my company, and you have here my webpage. We are a young company, but we have picked up, and that started for myself from CEFIC my CEFIC experience, and I started with SSbD from the beginning. And I just like to say that I'm available for anyone who would like to get support on this SSbD evaluation. And I think Lutz has presented it excellently, because it's a journey, it's extremely complex, and we have this EU SSbD framework, which is I would say, the ultimate objective. But like, if you think small companies, even researchers in universities, we have still a long way to go. So here is the scope of this IRIS project. What we have been working on in the last 3 years is to build up a permanent network. And that's a big challenge, because some of you, or many of you, will know that it's a very difficult objective when you're under an EU-funded project to build a permanent network, which is sustainable. But this objective is to build an SSbD community, and network was from the beginning, but now we call it SSbD community. And we are busy engaging partners, basically, to get a big SSbD community. But the ultimate objective, or the core objective, is the SSbD implementation in whatever way. And as Lutz explained also, it's about industry. And that has been the advantage of this project, is that we have worked along value chains to achieve more safe and sustainable products for society. So we've just gone a bit, we've widened a little bit the topic. SSbD has been presented on an EU framework recommendation point of view that was presented in 21, end of 21. We've done a tremendous work in trying to streamline a little bit what were the challenges and solutions for all value chains. I mean, not all value chains, but a number of value chains that have been working with us in the IRIS project. We have been also trying to put a focus on materials, but that includes the products, like the consumer products, and processes, like the textiles. And Lutz's presentation is a perfect example of the full life cycle, a full value chain, and looking at the textile material. We've worked a lot on cooperation mechanism, because, as you know, there are so many different organizations collaborating, and partnerships at the EU level. But also we wanted to have some insight, or we wanted to also talk with people outside EU to see how, they consider SSbD. And what we have kept all these 3 years, because the project is ending now, is a collaboration between industry, governing bodies like European Commission, but others, like also member states, and all the different projects, because there are many EU-funded projects working on SSbD. And another extremely important pillar of this project has been the skills and knowledge, and that's what I would call the education pillar. Here, I'm just starting in this. I mean, for you, chemical engineers, as I am, it looks very simple, but a lot of people just don't realize. I mean, even from the industry point of view, if you talk from a SME point of view, here you have the full value chain, And what I put in yellow on the right is all the different sectors that we worked with, like automotive, transportation, packaging, building construction, personal care. What we did there is work through the fragrances association. So it's like intermediate step for personal care, like for cosmetics and detergents, then textiles, then electronics, and finally energy, which I will try to give you a little bit more details on. So you realize the amount of work that has been to try to develop all these SSbD challenges. Lutz presented an example, and Catherine will present also on packaging, but in total it has been like 7 value chains working together. That has been a fantastic experience, and I just try to give you an overview there. So these are the 7 value chains we worked with. So as I said, textile packaging presenting today, but then also automotive, electronics, fragrance into cosmetics and detergents, construction, and energy materials. So here is important the people and the organizations, if you want to get in contact with them, if you're interested by a specific value chain. So importantly, first, the work package leader, like the leader of this value chains team has been Cefic, and I've been my company SSbD Consulting, as I am an ex-Cefic employee collaborating closely with them. Packaging, IPC, who Catherine will present just after me. Textiles, Lutz, ATP, then automotive. So automotive, it was like CLEPA, the Automotive Suppliers Association. They've done a tremendous job. Energy materials, it has been EMIRI. I don't know if you're aware, but the EMIRI now is transformed into this IMI new advanced materials public-private partnership. So it's still called EMIRI, but it's hosting now, and it's covering all value chains basically. But until recently, EMIRI was energy materials. Electronics has been represented by INL, the laboratory specialized in nanotechnology and involved in many projects on electronics. Construction has been represented by the Federation of Construction Chemicals. That was the best, because when you look at the value chain, it starts from the chemicals. So how many chemicals, how does it end up? And I think it has been also very useful, the work we did with them. And fragrances, as I said, one of the additives or important additives in the cosmetics and detergents value chain. So what we have done, so on the right side here, you see what we have been working on. Value chain per value chain is skills. What are the skills required for a safe and sustainable product development? What does it? It has been done through interviews with industry, big companies, small companies. What is missing? What are the skills missing? That's what the work we have been doing. Criteria is all the different dimensions that you have in this SSbD framework, which are so many, all the safety ones, all the LCA related environmental impacts, but that includes also, the safety during processes. I think here we are talking about processes a lot. You have exposure to chemicals, solvents, and so on during processes. So which criteria, as you're developing a product or a process, are you going to choose? And each value chain has been looking at closely at which criteria per sector is most important. And then the roadmaps, what is the roadmaps is looking at challenges. So we have done a big part of the project has been to look at challenges, but then we also want to propose solutions, right? So to a respective challenge, it has we have proposed a solution, and that's for each value chain. And all this team of all the different partners have done their tremendous work. So there are like 2 documents, and we are going to develop in the next months just like a joint document which will present all these challenges solutions for each value chain, and also look at the commonalities between the value chains. And that has been also a very interesting exercise, is what do we have in common and what are the differences, right? So now I'm just going to go onto the materials energy focus. I go back to the full overview after, but it's just to show you on this roadmap exercise what we have done on the materials energy side. So 2 case studies there. One is the solid electrolyte on lithium batteries. So these, as you know, I mean, SSbD, you can use, or you can try SSbD assessment on a development which is already accomplished. Like, you know, an example is like the phthalates, replacement of phthalates. So you just use a past research and development project, and you do an SSbD assessment like as a model, right? Here, we're not talking about past, we are talking about projects really running at the moment, and it's solid electrolyte, and that's a very big topic. And if we talk about circularity, one of the objectives is to increase efficiency, to increase safety, sustainability, while also maintaining circularity. And I don't know how much this has been talked about. I heard Antonis and Lutz, but unfortunately I was not present yesterday. But circularity is a very, very high priority topic for all on the SSbD overall framework. And there is always a link in all developments to circularity, and that's a must. I mean, we cannot avoid including circularity, and that's complex. And that's probably the highest complexity, I think, my opinion, is combining safety, sustainability through the LCA assessment, but including the circularity aspect, again, talking by design. So including this in your innovation process. So here, different solid electrolyte technology options, and what has been assessed, the SSbD dimensions are efficiency, performance. We want to get rid of the fluorinated salts, which are part of the process, unfortunately, and we want to improve safety, thermal stability, and not have any toxic gas release. So this is just like quickly advantages of the solid electrolytes. I mean, probably you all know, non-flammable, thermally stable, and have this reduced risk of gas release and thermal runaway, which I think is probably one of the biggest challenge today with a normal battery. and also enable the use of high energy anodes. The drawbacks, this is it. We were talking about trade-off. You do a development, you have many advantages, but then you have drawbacks also, of course. Interface of stability issues with electrodes and the cost. And in all developments, cost is always a challenge, and the process complexity. So the key focus there is identify, because there are many projects running on solid electrolyte. I'm pretty sure you know, a lot of you know, is identify the most promising system on both safety and sustainability perspective, and assess trade-off. And the key trade-off here, and that's where we go on the circularity, is performance of the battery versus recyclability, because as you know, the battery now needs to be poorer. You need to have the recyclable battery by the new battery directive, no? And also very, very important aspect, eliminate the use of fluorinated containing substances. So that's one first case studies. Then the second one is completely recyclability related, is how do you develop a wind blade which is recyclable. So there are also many projects running. The blades are really costly, complex, hard to recycle. They are made mostly, so currently, like you started from the polyester resin, now we have more made of epoxy resin, and we moved also progressively from fiberglass to carbon fiber, but they are all designed for strength and lightweight, especially when you want to be on the sea, and weather resistance on the sea. Current materials limit end-of-life options. That's the big issue, but there are a lot of very promising developments running at the moment. So the SSbD objective is really to assess the different materials for blades to enhance recyclability and sustainability, both of those aspects. On safety, it's still there. I mean, you can do a full SSbD. You have thermoplastic matrices, acrylic versus thermosetting epoxy polyurethane. But there are, I mean, again, you would know epoxy, that you have reversible now Vitramer technology developments. There are a lot of hope there that you can separate, basically the objective being to separate the fiber from the resin, right? So it's all about investigation of innovative fibers. So new carbon, like Vitramers, as I was saying, also could be combined with new carbon fibers, and then natural fibers also are part of the current developments. Yeah, I think I've said it more or less all here. Limited recyclability of thermosets, yeah. Material complexity, that's the issue of separation and reuse. Next steps is feedback from stakeholders in the wind, if we're talking about the wind sector, and more LCA and safety, like SSbD assessments of the proposed materials, because these are mid TRL, right? It's not like high TRL, so we need to do SSbD assessments of those. Then common challenges to all VCs, critical materials, implementing circularity. It has been very clear from all value chains perspective, that is, if not the highest priority. Eco-design, the digital product passport, and all value chains have in common that they have substances of concern, and that they are still being used in the industry. That has been recognized. Solution, the supply chains, the secure, sustainable supply chain, and find sustainable alternatives for the raw materials. Circularity, change the focus to improve decontamination. Legacy products, when you're talking about chemical recycling and so on, you have to go to some processes which allow that you don't have any legacy products in your recycling process. Then opportunities ahead very quickly now, 2 seconds, 3 seconds. Strong collaborative community.
Yeah.
I think I got that clear. We have all these value chains, they have committed to work together in this platform. So this is IRIS platform, and we are going to deliver many services. So just like join as a member on the IRIS platform. So what is happening is that we are finishing this project. So please join before end of May, then you have better chance to be, you have full membership at the moment. And from June on, you still have a free membership, a membership access for free. So anyone can access, and basically you will still, after June, the more we will have like 3 different membership accesses. I think it's important to say that anyone still can join.
Okay. Thank you very much, Andre. Thank you very much again. I'm trying to cut it short here, in case we have any questions. I would like to remind people that they can put the questions in the chat. I understand that we have a very, very quiet audience today. I don't want to leave you out of the room without a question. So let me ask, something. I asked a similar question to Andreas and Sophie yesterday, you have to know. And I asked this question, given your very heavy involvement on this IRIS project and so many other similar things, and the different value chains that were studied, under IRIS. SSbD is a very exciting, embracing, inclusive concept, yeah, but it's pretty conceptual at the moment. So my question is, how far we can get SSbD to a tool, something like an ISO, yeah? Something that will deliver a measurable kind of output for our analysis. How far, let me put it another way, can we get it to a level, similar level of LCA, which is established, it's still dynamic, yeah, but gives numbers. And this is the way
still
people,
complex.
Otherwise, always you will find trade-offs, plus pros and cons and whatever. And I'm not sure how you can share all this analysis in a convincing, committal way to the people who will make decisions. So again, given all your exposure, experience, and your strong technical background, because at the end of the day, you are an engineer, so you understand
Yes.
our community numbers, yeah. How far you think we are getting to this stage?
Well, that's a very good question. I'll just give you an example because that's what I think, starting with SSbD and seeing it as very complex, and LCA is already complex, and that not small companies can perform LCA easily. So you're adding the safety, you're adding the circularity. So that's my aim, is that to have developed tools which are simple enough for SMEs, for small companies, especially in the downstream, because more downstream you go, more SMEs you get.
Yeah.
So all value chains are concerned by this, and they want to have this information. I mean, we talk about this traceability and so on, but So there are two things, is like convince SMEs, and especially the innovative SMEs. And I have actually planned next week a workshop for our startups in collaboration with ISE3, including startups from outside EU. And I'm having very interesting discussions is, you know, in your innovation, they are innovating. What have you been using, you know, in a simple way? I mean, it really takes time. I've spent with each startup at least an hour to exchange on what are the different aspects of SSbD that you looked at, and you know, how do you see this, and so on. So I think that's one way to go, is really to understand exactly downstream startups, innovative, working on formulations, working on even on processes. Like I was like talking, one of the startups is making biochar and pyrolytic oil in South America for the soil, as a replacement for the like all from biomass, based on biomass, but fantastic innovations, but they don't have a clue what SSbD is. So my reply there is that we have to make a connection there between all these innovative SMEs, and so we have to build an ecosystem. And I think in IRIS we are ready for that. We will do that. And another point is digital tools. I mean, without development of digital tools, we are nowhere, and the use of artificial intelligence also. And that's it. Yeah. Sorry, I'm long.
No. Actually, it's a good answer. Actually, the way you hint this one is that other than digital part, which is obvious, especially on the transparency part, you know, that is a prerequisite for SSbD, is also that it reminds a lot to the effort of LCA itself to become a little bit simpler, because simple models is the one that you mentioned, in the way that they have this ex-ante LCA. Ex-ante LCA means also simpler LCA. You know, pre analysis of the system before you come into the very details, you know, and the very detailed numbers anyhow.
Yeah.
I think we would have to stop here because Catherine is in her way to enter the podium. Thank you very much, Anne-Claire. We'll keep in touch, you know, we'll certainly.
Thank you.
And let me then get to our next final speaker, Catherine Colin. Catherine Colin, she is a research program manager in the environment and health, you know, at IPC, the French Industrial and Technical Center for Plastics and Composites Industry. She has managed Schneider Electric environmental program for 6 years, and has created a consulting company in environment and sustainable building, Quellis, if I pronounce well. She's a lead green associate and well. I mean, for those who don't know, LEED is the world's most widely used green building rating system. And she's with us today to address a rather important part, which is plastics and packaging. So, Catherine, please, you know, set the podium, and thank you again for being with us today. We wish to make it. Well, thank you.
Thank you. So thank you for the kind introduction. And so I work within IPC. It's in France. It's a technical center for plastics and composites, and I am also chairman of a SEN standardization committee, which is SEN TC 462, about regulated chemicals in products. Today I will describe you the packaging value chain, explain how we practiced SSbD on a packaging film case study, and finish with challenges and benefit from SSbD practice. So to introduce packaging value chain, what is noticeable is that packaging industry use a lot of material resources. If you look at the figures, you see they are high consumer, and it's true for paper and cardboard, for glass, and as well for plastic packaging. And as the lifetime of packaging is shorter compared to other product categories, it ends up in heavy or important amount of waste, which were about 84 million tons in 2022, and which Europe regulates to obtain a reduction of packaging waste. If we look at the market of packaging industry, you can have as well big companies as small companies. It's not one packaging company to provide the packaging. It's a segmented industry with a complex value chain. And now that recycling and end-of-life treatment is under deployment, it doubles the number of implicated stakeholders. And we also have frequently SMEs within the value chain. It's frequent to have very small companies with less of 20 persons included, and small R&D teams are also frequent, like R&D teams made of 5 persons approximately. What is the status of SSbD practice within packaging? It's already an established or deployed aspect through safe and sustainable mandatory criteria coming from EU regulations. A major regulation is packaging and packaging waste regulation called PPWR, which came into force at the end of last year, and which is under application. And compared to those regulations with safe and sustainable criteria, SSbD recommendation framework is bringing a specific consideration, which is to tackle the whole life cycle. So practicing SSbD means a new aspect, which is looking at the complete supply chain and getting data from upstream actors up to downstream actors. If you put packaging on the market as a downstream actors, you need to collect data about the material and ingredients that are within the packaging, as well as what is the sustainable performance of the processes that you practice. And it needs a lot of information from material or upstream actors. And if you are upstream actors deploying a new material for packaging applications, if you want to look at it SSbD performance, you need to gather data on what will be the exact application and use condition, and also what are the end-of-life processes or treatment that enables to have a recycling on place for the packaging. So somehow, practicing SSbD framework pledged for a better and simpler value chain, more local, which is in line with European procurement autonomy strategies or wish from the European Commissions. If you have a simpler supply chain, you can have more direct information, about the material and ingredients, as well as about the processes and their sustainable performance, like what is the decarbonization progress of the processes. I will describe an example of a case study of SSbD for packaging. It has been deployed within Surpass Horizon Europe project. Surpass is a project where stakeholders from SSbD expertise as well as design experts in 3 domains are gathered. The project will end up in November of this year. We had targets on obtaining safe, sustainable, as well as recyclable, innovative solution and practice their SSbD assessment. For packaging case study, we considered packaging film. Here we are designing a new kind of technology for packaging films, which is multi-nano layered film. It enables to have more monomaterial solution. It helps to reduce material resources and obtain recyclable packaging. So practicing this new technology to compare to conventional multi-layer films enables to have less material used to produce a packaging film and obtaining at the end a recyclable film was our target in order to obtain a good, safe and sustainable performance. SSbD is not only focusing on safe and sustainable criteria, it was also taking a deep look on design and functionalities. That's why we also practices and looked at the functionality characteristics and criteria. If we look at our practice, so Lutz explain you the design principles. I will more focus on the SSbD assessment, which somehow is coming at the end of a project in the life cycle or the stage gates of project. The full assessment is ending at the end of the R&D project. But you can start at early stages by deploying an iterative approach. Within Surpass, we almost started from scratch. That's why at the beginning we looked at GRC SSbD steps and criteria. So we consider all aspects: hazard, exposure, LCA, as well as social and economic aspect with life cycle costing. We build methods to evaluate hazard, exposure, LCA, and cost. And we selected hotspot or gap or looked at existing gaps and data needed to do a first assessment. It was followed by experimental evaluation or modelization to obtain the results on the different criteria: hazard, exposure, LCA, and LCC. And we obtain these experimental or modelizations SSbD results, which are now gathered into a unique score, which will be computed on a digital infrastructure to be able to share within value chain stakeholders SSbD information and performance. If we look at the examined alternative and solution we took look at, so you can see that it is we did a comparative approach where we compare the innovative solution, Surpass new packaging film, with a current commercialized packaging film. you can look at, in terms of material design, we have very similar materials, but a completely different way of producing the packaging film, and the formulation and design principle are completely different. And the large variance is for the end of life, where for the alternative we have on-place recycling with innovative process, including waste decontamination. So which it brought us to understand that the maturity level is very different from alternative to commercialized products, and we needed to take this into account in the SSbD assessment. You have here a sum up of what was our SSbD practice within Surpace. Going for an iterative process where we had a more quick tool at the beginning, followed by complete assessment in late stage of the project, to obtain a complete assessment taking into account all criteria from SSbD framework. We consider the entire life cycle. It doesn't mean that we collect and measure everything. We did a selection based on identified hotspot, and we combined the examination of functionalities and safe and sustainable criteria, which you can see at the bottom of the page, with some necessary characteristics and performance, accompanying the safe and sustainable performance, which enable, for example, to have a recyclable packaging. If we look at how we practice and perform each specific assessment for exposure, we looked at the value chain and existing processes along the entire life cycle. That's why we needed to do a selection of most important hotspots, which enable to have a realistic assessment of the release and exposure. And we took a look at, for selected processes, at some emissions, and did some experimental quantification and measurement. For hazards, the principle was very similar. We did a selection of hotspot and collected ecotoxicological values for that. We did as well modelization and experimentations on hazard assessment. And we were having toxicity specialists and experts within the project team, which was a benefit to practice hazard criteria on LCA and LCC. So we perform the measure of environmental performance and economic performance. We selected evaluated impact categories, both for environmental aspect and cost aspect. And we did a large data collection and inventory of necessary information to compute the environmental and cost performance. This is where we examined a maturity difference in the alternative, and we decided for methods where we extrapolate innovative solution data to put them at industrial level and be able to have a fair comparison of the SSbD alternatives. To explain you how we proceeded and what we did, I selected to detail the exposure assessment done for the processes. So on the production, we consider the entire life cycle. For product manufacturing, we selected two hotspots, which are two processes where emission of volatile elements, non-international added substances called NIAS, and microplastic can be released. So this possible release was quantified by measurements and experimental quantification of the categories, which chemical elements are present and what quantity are founded. For use, we studied how from the packaging you can have some NIAS into food. So we perform migration tests to quantify and examine this release. And for recycled, we looked at possible contaminant present into processed waters used during recycling, and we also examine emitted microplastic or nanoplastic during recycling process. We computed, so from this we obtain final SSbD results of the packaging alternative developed within Surpass. The results will be published in Surpass final deliverables. They comprise many data and information in terms of LCA, LCC, release exposure, and hazards assessment. We combine all these criteria into a unique scoring, which will enable to compare the benefits and bonus and malus obtained from the new solution compared to a commercialized product, and this will be included in a digital platform. An important aspect is the aggregation of data that happens at this stage, especially for LCA and LCC. We collect raw data, which are aggregated and computed, and we progressively obtain information which can be either confidential or with restricted aspect, or public information that could go up to end consumers. To conclude with the practice of SSbD within this case study, what we relate as main recommendation is to go for an interpretive assessment. As I explained, in early stages, we want to be quick in the evaluation and evaluate many possible solutions to select the best one, as well as we select the best technical solution. We want to select the best safe and sustainable solution. We also need techniques and methods to make the full assessment at the end of the project. And for this, we need to identify SSbD hotspot to focus on point of importance. It is important as well that the selected hotspots are recognized by SSbD expert as well by safety or sustainable expert and also by the value chain domain. It is important that packaging companies recognize the selected hotspot as main points of importance. And a third aspect, which is key to obtain valid SSbD assessment and performance, is to use high-quality data. If your data are not reliable or accurate or not recent, you will have an evaluation which is far from the operational solution you are designing. And we have noticed that designers are keen to have the closest data compared to their design and their practical material, ingredients, as well as processes. This is why many Industriel prefer to pay for SSbD assessment tool, like it is the case for LCA, with major LCA tool being a majority of the practices compared to open data tool, for two reasons: to have very accurate data, and also to protect the confidentiality of practiced SSbD data. I will finish with detailing some challenges and benefit of SSbD practice for packaging. So first, let's start with challenges. So a challenge that is present in terms of safety for packaging is to be able to include safe recycled content in packaging with PPWR regulation. We need to deploy the use of recycled content into packaging with mandatory percentage of recycled content included in a new packaging. Two ways can help to practice more recycled content into packaging. A first way is not on the packaging itself, it's more to change consumer habits and go for reduction of used packaging as well as new packaging design, which will enable to necessitate less packaging materials within a certain country or market, and this will go to reduction of EU packaging waste. It needs another needed action is to deploy new recycling processes, especially those which will enable to decontaminate plastic packaging waste or other material packaging waste, to be able to have them back into food packaging production. To practice SSbD, it is essential to educate about hazard criteria. Some major things are known on hazard, for example, the compliance to REACH rule and respect of regulated substances. It is less easier to anticipate coming regulation and understand detailed criteria and principle of safety. Therefore, the importance of education on this aspect, and it means not only education of safety specialists. It's better to have multidiscipline trainings, which enables design, purchasing team, and future engineers to understand the main points of safety. Another challenge which we tackled is to face and deploy the necessary substance substitution coming from substance regulation and toxicity evaluations. In this way, it's better to consider group of chemicals compared to substance by substance regulation. The more industrial are able to anticipate coming regulation, the better they can optimize their R&D roadmap on putting up alternative to regulated substances. We have noticed that from the phthalates regulations, successive substitution could happen within some value chains, and that the companies who anticipate it and select more innovative substitution benefits of less successive project to run a substitution. Another important factor is to interoperate data along the value chain. I already mentioned the confidentiality aspect and need of accurate data. Digital tools are very useful and needed for this, and the practice of digital product passport could be an example of how to integrate and deploy SSbD along a value chain. I will finish with the benefits of SSbD for packaging value chain. When we practiced SSbD, we considered the entire life cycle. So it's a benefit because we come up with a more complete, innovative solution, which will gain more recognition on the market. And the SSbD framework helps to harmonize methods and tools to evaluate safe or sustainable criteria. Not everything is harmonized. We still need to do some trade-off, but it push into going for harmonized criteria and methods. The wide application parameter of SSbD framework is a bonus and a plus because we practice the same vocabulary, and it enables to group and make exchanges, collaboration between very different disciplines. Through SSbD practice, design teams could talk and exchange with toxicity experts, which is not a frequent situation in nowadays R&D projects. It happens within chemical industry, but within packaging in value chain, few design teams have direct access to toxicity experts. So this is an obtained benefit from deploying SSbD framework. And we also notice that we have a better mastering or confidence into packaging value chain when we practice SSbD, because it requires better traceability within the value chain concerning ingredients and processes, and it pledges also for more direct and simpler exchange within the supply chain and different stakeholders. That's it for today. Thank you for the listening.
Thank you very much. Thank you very much, Catherine. I'm waiting as a priority comments from the audience. It has been a very important supply chain, the one that you reviewed, Catherine. Wouldn't be fair if we don't ask you some questions, in your presentation, you very nicely drew comparisons, between SSbD and LCA, and you very specifically provide the results, not just, big references. You also explained, as Antois did, just before you, that these early calculations are very important to review early and simple calculations ahead of detailed decisions. Yeah. My question, comes down to this part. How different, say, this analysis you presented, is from LCA? Let's say, what? Let's put it another way. If someone does apply LCA only, yeah, as someone who applies SSbD, yeah, what kind of different results have we? Do we see, in the SSbD approach rather than the LCA approach? Because, as we all know, SSbD has, as part of that, the sustainability through the life cycle, but also LCA has it, yeah? But it has many more. It has the innovation, it has the transparency, the responsibility, the prevention, all this kind of stuff. So where we see that, in as different kind of outcomes from the analysis.
So if you
So the question is, if I do that LCA, if I do LCA across the entire life cycle, and if I do SSbD, yeah, what are the differences in the results I will get from the two different approaches?
If you do a LCA, you will focus on environmental criteria, and you will some safety criteria. There are some indicators on health in LCA, but for example, on your pigment selection, or color selection, you might let by side some pigments which can be which can be concerned by potential substance of concern. For sure, I guess you will also consider REACH and make sure that you don't have forbidden or restricted pigments and colors. but you might not look at some emission occurring during production or use through volatile component, for example, and also not notice that an ingredient is not restricted today, but is already identified substance of concern. So it is you will not have with SSbD you have a much more complete overview of the safety criteria, which is important to deploy for the packaging industry. There are many ongoing substitution for packaging, and I have on mind the PFAS coming restriction, which with some substitution currently ongoing for packaging industry. So this is an example where you will not consider the same SSbD parameter is wider.
Okay, so I would like to thank you again for the presentation. I would like to thank everyone for this other spotlight. Well, would you like to say something? If you wish, you can do.
Yes, indeed.
Yeah, sure.
Thank you very much, Antonis, for setting this up, and thanks a lot for all three speakers of this morning to give yet another series of deep insights in how SSbD can be applied in our analysis of our processes. It was very insightful to see various application areas, such as in the textile industry, but also to have the entire value chain on the screen, and which impact factors are important to consider. Chemical engineering is not just reactor engineering and separations. We should really consider our place in society and integrate with other actors. And I'm very happy with these three very interesting talks this morning. Thanks a lot, and have a nice day.
Finally, we would like to thank also the people who attended today. So thank you for the audience, and above, once again, thank you, Martin, for organizing all that. You're hiding behind, but we know that you have been, the instrumental person, for setting up. And we thank you very much for that. And I would like again to declare, the session closed. And thank you very much, and have a nice rest of the day. Yeah. All the best.
Bye-bye.